Hi everybody, in this video let's learn about linear law. So in this chapter we are going to learn how to reduce a non-linear relations to the linear form. Okay, let's look at this one. y equal to x squared minus 4x. This is a non-linear relations. If we draw the graph for this function y against x, we will get a curve, right? These are quadratic functions and we will be able to get a parabola shape with a minimum point. Okay, let's see how do we draw this curve. I think it should be no problem. First, we construct a table. X, Y. Okay, I think I just show you 5 points. 1, 2, 3, 4, and 5. We need the value of y. After that, after we get all the value of y, we plot the point and we connect them together. How to get the value of y here is actually very easy. When x is equal to 1, you plug in 1 over here. 1 squared minus 4 times 1. You can use your calculator to help you if you want. You will be able to get negative 3. When x is equal to 2, plug in 2 over here and here. 2 squared minus 4 times 2. Okay, negative 4. Do the same thing for the rest of the value of x. Negative 3, 0, and 5. Now let's see. When we plot all these points, we connect together all of them. What is the shape of the graph? Okay, so now I need the axes y and x. The first point is 1, negative 3. 1, negative 3. The second point is 2, negative 4. 2, negative 4. Then 3, negative 3. 4, 0. And 5, 5. So this is definitely not a straight line, right? So if you connect all these points together, you will get a curve. So now what we need to do is to change these non-linear relations to linear form. Means that after we change it, we draw that graph, we will be able to get a straight line. Okay. So when we talk about straight line, we always think about this. Y equal to mx plus c, right? Y equal to mx plus c. Y equal to mx plus c. We can write the function in this form, then we will be able to get a straight line. And this is a constant, and the m here is a gradient. I hope that you still remember. Now, you will notice that for this both terms, they also have an x variable. We don't want this form. We want to change one of them, become a constant. So how to do that? Let's see. I divide the whole equation by x. If I divide this whole equation by x, what will happen? So just now I told you we want one of them become a constant, right? So after I divide this whole functions by x, here will be y over x still remain unchanged. Here will be x squared divided by x is equal to x, and this will be negative 4. Now we got a constant here, no more x. So this is a linear form. It means that if we draw a graph y over x against x, we will get a straight line. Now compare with this form, y equal to mx plus c. We know that later if we draw a graph y over x against x, we get a straight line with the gradient of nothing here. It means 1. 1 is a gradient of that graph. And the y-intercept here will be negative 4. Okay, to draw this graph, we need the value of y over x. What should we do is we add one more row here. Okay, this is for y over x. How do we get the value of y over x? It's easy. This is y, this is x, right? You just take this divided by this. Negative 3 divided by 1, you get negative 3. Negative 4 divided by 2, negative 2. Oh, I think I use black color. So this is negative 3, and then this is negative 2, this is negative 1, this is 0, and the last one is 1. Okay, now I have to focus on this row and this row. Okay, let me plot the graph and then connect all the points together, see what is a graph that we can get. Now I need the y against x. I want y over x against x. Okay, so y over x. So I need to plot the point first. The first point is 1, negative 3. 1, negative 3. Okay, will be over here. 1, negative 3. The second point is 2, negative 2. Correct or not? Okay, correct. 2, negative 2. And then 3, negative 1. 3, negative 1. And then 4, 0. The last one will be 5, 1. Okay, so now I connect all these points together. I get a straight line. The straight line, the gradient of this straight line is equal to 1. You can try to calculate. And the y-intercept is negative 4. As I told you just now, this is the y-intercept. So this is a way how we reduce a non-linear relations to a linear form. Okay, so let's look at some questions. Okay, let's look at this example number 6. Reduce each of the following non-linear relations. All of the relation here are non-linear. They are not a straight line. To the linear form. You want to change it become straight line. Identify and state the quantities represented by y, x, m, and c. So we want to change them to this form. Y equal to mx plus c. So for this type of question, sometimes we will get different students might give you different answers. Okay, why I say so? Look at here. Remember, our purpose is change one of them become a constant. We want this form. Here is a constant. So how to do that? I can divide this whole equation by x squared. So now I have y equal to 3x cubed plus 7x squared. If I divide this whole equation by x squared, here will be y over x squared, and this will become 3x, x cubed divided by x squared, you will get 3x. And here you will get 7. Now from here, you compare with this pattern, this form, y equal to mx plus c. If you draw a graph, y over x squared against x, we will get a straight line with the gradient of 3 and the y-intercept of 7. This is 7, and the graph is going upward because the gradient is 3. So the big Y is y over x squared. The big X is still x. The gradient of this graph will be 3, and the y-intercept will be 7. Okay, let me check it or not. 3, 7, y over x squared, and then x. Yes, correct. So some students might do it in different way. So for example, some students might do in this way. Y equal to 3x cubed plus 7x squared. Okay, they just divide this whole equation, whole functions by x squared, x cubed. So I divide this whole function by x cubed. Here will become y over x cubed, and this will become 3. This will become 7 over x. Okay. Now I try to rearrange all this term so that I can see the form y equal to mx plus c. 7 over x, I can write in this way. And x. Okay, so plus 3. So from here, I know that if I draw a graph, y over x cubed against 1 over x, I will be able to get a straight line. The gradient is 7 and the y-intercept is 3. Okay, this is 3. The big y is y over x cubed. The big x is 1 over x. The gradient is 7 and the y-intercept is 3. Okay, so some student might be thinking, so how do I know in the exam I want to do this way or this way, right? You don't have to worry because the question will tell you what to do. Okay, let me show you some past questions. Okay, we look at these questions, 2016. Look at the questions. Plot xy against x squared. They will tell you what to do, what graph to be drawn. Okay, let's see 2017. Plot xy against x. Every year will be the same. They will tell you what to do. Plot y squared over x against 1 over x. Okay, you just follow the requirement of the questions. Okay, let's go back to our note. So let's say some students want to do this way or this way. How about if we try do this way? Now I have y over 3x cubed plus 7x squared. The first method, I divide this whole function by x squared. And the second method, I divide this whole functions by x cubed. How about now I divide this whole function by x? So here is y over x, and this is 3x squared, and this is 7x. This method is not suitable, it's not correct, because why? This is not y equal to mx plus c. You will notice that here, we don't have a constant here. This both also have a variable which is x. So this is not a linear form, not y equal to mx plus c. We don't want this. We can do it this way or this way. Both are correct. So it depends on the requirement of the questions. If the questions ask you to draw a graph, y over x squared against x, you do it this way. If the questions ask you to draw a graph, y over x cubed against 1 over x, then you do it this way. Okay? So let's try the next part. Let's try part B. Y equal to kx minus h over x. Okay, we want to change it, become this form. We want to reduce this non-linear relations to this form. We want a constant here. So what to do? We can divide this whole functions by x. If let's say you divide this whole function by x, you will get this. Y over x. Kx divided by x, you get k. And then if you divide it by x, you will get x squared. Okay, so I rearrange all this nicely in this form. So it will be easier for you to know which one is gradient, which one is y-intercept. Okay, so negative h. Okay, I change become this. I write in this form, easier for you to get the gradient and the y-axis. Oh, sorry, x-axis. Okay, let me check around now. Okay, so this is already in linear form. With the big y is y over x. The big x is 1 over x squared. And the gradient is negative h. The c, the y-intercept is k. So if you draw a graph, y over x against 1 over x squared, you will get a straight line with the gradient of negative h and the y-intercept of k. So let's say if we don't want to do this way, we can do it another way. Y equal to kx minus h over x. I just multiply this whole function by x. Here will become xy. This will become kx squared. And this will become h. Okay, so because h over x times x, it cancels up, you will get h, negative h. Okay, so the big Y, the big Y is xy, big X is x squared, the gradient is k, the y-intercept is negative h. If you draw the graph, xy against x squared, you will get a straight line with the gradient of k and the y-intercept of negative h. Okay, so this is the way how we reduce a non-linear relations. Okay, let's go part C. Y equal to 2x power 6. Y equal to 2x power 6. This one, if you don't want to do anything, also can. With this, let's say, if you want to draw a graph, y against x power 6, you will be able to get a straight line with the gradient of 2 and with the gradient of 2 and the y-intercept of 0. Something like this. Okay, why? Because this is y equal to mx plus c. The c is 0, the gradient is 2, and the y-axis is y, the x-axis is x power 6. But normally we do not prefer to do it this way because the x power 6, it will become very small or very big. It's not convenient for us to plot it. So we have another way to do it. We can do it using another method, using log. So I add log base 10 to both sides. Whatever I do on your left hand side, you have to do the same thing on the right hand side. Okay, log this whole thing. Okay, this part we can break it become two parts. I hope that you still remember. Plus power 6. And one of the properties of log, we can bring down the power over here. Bring the 6 go down here. Okay, so now I rearrange all these terms nicely so that you can see which one is gradient, which one is y-intercept. Okay, log base 10 of y, okay, 6 times log base 10 of x plus, okay, correct. So if you draw a graph, log base 10 of y against log base 10 of x, you will be able to get a straight line with a gradient of 6 and the y-intercept of log base 10 of 2. Okay, so the big Y is log base 10 of y, the big X is log base 10 of x, and the gradient is 6. The y-intercept is log base 10 of 2. Okay, so this is the way how we deduce the nonlinear relations. Okay, so for this video, I stop here first. I will continue to discuss with you some other questions in the next video. See you next time. Bye bye.